OG Culture presents KemPTah Mathematics, Nefer Doubling and Multiplication, the huti calibration. Doubling is the black multiplication. The reason I took you through doubling, because doubling is a black multiplication. What do I mean by that? Doubling deals with multiplication based on 2, which is the first number after the complete synergy of 1 and 0. 2 is the first number that doesn't have the essential qualities of 0 and 1. Now let's look at the qualities of 0 and 1 so we get a better understanding of 2's position. Most people know that 0 multiplied by any number, however small or large, is 0. This means multiplying any number with 0 will bring that number out of its own relative difference and into the origin, which is 0. Number 1, on the other hand, conserves the qualities of numbers. That is why any number times 1 is the same number multiplied by 1. You know, if you multiply 5 times 1, it's going to be 5. Any number times 1 is that number that you multiplied with 1. The synergy of 0 and 1 creates not only transformation of quality into quantity, but also the synergy of destruction and construction. Hence, therefore, when numbers are multiplied, the relative isolation of numbers are destroyed thanks to 0, and their inherited qualities are passed over or passed down thanks to number 1 over to the product. 2 represents the most basic multiplication, regulated most directly by 0 and 1. That's the next number. 2 is the most. That is why doubling can be used as only multiplication. All other numbers above 2 ain't going to be consistent. 2 is the multiplication marker, as 1 is to addition. 1 can subtract progressively from any number to get 1 or 0. 1 is the main number besides 0 that is the backbone to counting. 2 counts not by like progressively or adding in series, but multiplying in series. Ancient Kemetic multiplication is a black multiplication because they can find any solution to any multiplication problem just by doubling and adding the appropriate numbers, of course. Any numbers above 2 will miss this mark, or the calibration will be left off. Just like in addition and adding, if you keep subtracting a number by 2, because addition 2 is far from being the source number, you might not make it to 0, you know. For instance, 1 subtracted by 2 is -1, but the basket, that the point must be made is 0 though. Same thing in multiplication. If you triple it instead of doubling it, certain numbers will miss its mark. So, you know, 2 is the most consistent number after 0 and 1. You know, I figured out Nefer calculation by ancient Kemetic doubling. The ancestors taught me. Nefer calibrations are the most easiest in demonstrating the power of doubling. Doubling is internalized in the KemPTah multiplication. Of course, we're standing on the shoulders of ancestors, you know what I'm saying? Kushite, Kemetic, you know, Ashanti, whatever tribe, all the progressive elements as one. I noticed too that in Kushite multiplication, Hovin doesn't have to be proportioned neatly to get the product. In Hovin, inverse black multiplication, 7 for instance is halved to 3 instead of 3.5. And the family still get the correct answer when they do that Kemetic calibration. The center is called 0. So, you know, we base value on how less something is and how it could produce more from less, you know. How you could use little energy to get big energy, you know. You mastering a brick to build a building. 3.5 is more like 4, so it's a little further than 0 than 3. I know it seems weird, especially when we was conditioned by consumerism, and that leaks in how we calculate in mathematics too, because everything is a synergy of size. Not even Europeans could escape that fact, you know. Misconception of math comes from the law of identity crisis. Weak conception tend to bulk up to appear stronger. One point I want to make is that integral part of multiplication is adding, specifically never addition. Multiplication cannot escape addition, just as 1 cannot escape its connection to 0. What's within is so throughout. KemPTah multiplication to huti calibration, far superior than Eurocentric multiplication. I call it the huti calibration because we calibrate 2 single digits at a time, and when we dealing with double digits, we use a combination of adding and multiplying numbers together, plus we do cross multiplication and adding the product to find a synergy or a center of the product. If 2 single digits are multiplied together, another single digit is the product of that, then that single digit that was made by multiplying 2 single digits do not participate in never or horizontal adding, but accepts a carrier number at best. All double-digit numbers are never added from right to the left. The last digit on the left accepts carryovers of numbers, but the rightmost digit of the product do not. Both do not participate in never addition because they represent 0 and 1, meta KemPTah. All double digits in the middle participate in never addition. Now that we know the general rules, let's go into specific calibration. In 592 times 8, we multiply 8 with each digit. We don't do no carryovers or nothing like that. After we finish multiplying each number, then we count how many pairs of double digits we're going to add horizontally by never addition. Any number after the first number on the left shows how many pairs we add. Hence we have 9 and 2 located on the right of the leftmost number 5. 9 and 2 multiplied by 8 individualistically yields 2 numbers, double digit, things, numbers, double digit numbers. Remember, double digit participate in never addition and not the single digits. That was one of my points on introducing the black decimal, 0 and 9. 0 and 9 do not never together. Numbers from 0 do not add neverly. They don't add horizontally. But any number above 0 and 9, they add together. So in 592 times 8, notice we never the 0 with the 7, the 2 with the 1. Notice the ends are not touched, but directly passed to the product. Hence we get 4,736 as our answer. In multiplying double digits, we look at the problem KemPTah, meta KemPTah. First, we find the synergy, center, the heart of the product, by cross multiplying and adding the product together, which give us 43. After that, we multiply the sides with the meta KemPTah represents sides which meta KemPTah represents as 0 and 1 in their relative independence. After that, we count how many times we must never add them horizontally. If you're dealing with 2 digits, then we count it twice. Since we multiply 2 digits with another 2 digits, we gotta count that 5 that we counting as 1 never if we was doing single digits with 2 digits. You know what I'm saying? We gotta count it twice because now we dealing with Not one number multiplying multi-digits, but two numbers multiplying with multi-digits, and they pair off as 2 digits each. So this might be a little complicated, because all I'm saying is, like, all you're doing is just cross multiplying. Boom, that's the middle. Then you multiply the sides and you just add it together on the sides. Boom, stitch it together like fabric. It comes in handy instead of like writing all them zeros and try to add it together. See, the way I wrote it, it looks like it's a long process of doing this multiplication, but once you start getting used to it, all you're doing is shifting numbers around, so you don't have to do that many calculations. You're skipping steps through movement. That's why I built this simple, crude slide rule version of the how you really multiply. You can just see we just slipping back and forth, and we cross multiplying. That kills the putting digits on top of each other and try to add it off and whatnot. So it's a faster way. You'll see when you start practicing this, it's faster than the European multiplication. When you're doing, especially with large numbers, because the European got the broken iron rule, so they gotta make up steps to make up what they don't have. So just like this problem, 54,567 multiplied with 22. When we multiply with 22, what we do first is look at it KemPTah Doubling. We cross multiply, so we could get the middle right. Saying on the one side, when you look at the whole numbers as it is. So we get 26 when you cross multiply 6 times 2, 7 times 2 is 14. 12 added together, you get 26. So after we finish doing that, what we're doing is next is multiply 7 times 2, which represents the one side of that particular interaction between these two numbers, the large number and that 2-digit number. So after that, you move to 22, cross multiply again. It's like you're repeating the process, but on another level. It's like a sperm. That's how it goes. And you cross multiply, boom, and you add the products, which is 22. You don't add the sides on this one because the middle part of the number right there is no sides. So we don't do the sides. We don't multiply the sides. We're in the middle of the number we're trying to multiply 22 with. So the middle of that number don't got no sides. That's where we at. That's the location of the number. So we we go one digit forward towards the left, then we cross multiply again, and what we got is 18. We don't do no side multiplications yet. Put that number down. Next, we go one digit forward and we cross multiply 5 times 2, 4 times 2. What you get is when you add the products, you get 18 again. So, because 5 times 2 is 10, 4 times 2 is 8. Add them together is 18. So we figure out that synergy. But we on one side, we on the left side now. So what we do next is just multiply vertically on the 0 side, and we complete the multiplication. After we do that, what we do next is add it together. We know how many digits it is that we got to add together. So since at one point certain numbers, when you multiply, it doesn't give a double digit, we don't multiply that. So altogether what we have is 5 additions. We doing never calculations. We adding to them together in pairs 6 times. You know what I'm saying? You got the 6 with the 1 right there next to 26 and 14. They get added together. 6 and 2. I mean 6 and 1. When you add it together is 7. We do the same thing with the 2 2s. The 2 on the 22 and the 2 on the 26. We add them together. That's 4. And then we go. You know what I'm saying? It's like front and back. You know what I'm saying? Like alternate. That's the rhythm of the formula when you add them horizontally. So you got the 8 and the 2, which is the 8 from the 18, 2 from the 22. We add them together. We got the that makes 10. So we had to, you know, we had to carry that number over when we add the 8 with the 1, which make another 10. Then we carry that number over. 1 and 0, and add the 1 we carrying over. That's 2, and then that's it. You get your answer. The answer is 1,200,474. And that's the answer. I also made the just to show you the movement, the general tendencies of the KemPTah multiplication.